Hi students, welcome to my next lecture on projectile motion, which is given in chapter number 4, section 4.10 of physics for class 11. An object that is in flight after being thrown or projected is called a projectile. Such a projectile might be a football, a cricket ball, a baseball, or any other object. The motion of a projectile may be thought of as a result of two separate, simultaneously occurring components of motions. One component is along a horizontal direction without any acceleration, and the other is along the vertical direction with constant acceleration due to force of gravity. It was Galileo who first stated this independency of the horizontal and vertical components of projectile motion in his dialogue on the great world systems. In our discussion, we shall assume that the air resistance has negligible effect on the motion of the projectile. Let us start. Projectile motion. A particle moves in a vertical plane with some initial velocity vector u, but its acceleration is always the free fall acceleration g, which is downwards. Such a particle is called projectile, meaning that it is projected or launched. In the figure shown on the right hand side, O is the origin and we have two axes, that is x-axis and y-axis. The particle is launched with an initial velocity u and at an angle theta. One of the important example of projectile motion might be a golf ball or a baseball in flight, but it is not an airplane because airplane operates on fuel. There are certain assumptions of projectile motion. These assumptions are: there is no resistance due to air, the effect due to curvature of Earth is negligible, the effect due to rotation of Earth is negligible, for all points of trajectory, that is the path of projectile, the acceleration due to gravity g is constant in magnitude and direction. The principles of physical independence of motion is applied in discussions on projectile motion. The motion of a projectile is considered as a two-dimensional motion. So it can be discussed in two parts: horizontal motion and vertical motion. These two motions take place independent of each other. This is called the principle of physical independence. That is, we consider the motion in two separate components along x-axis, horizontal and vertical. The velocity u of the particle can be resolved into two mutually perpendicular components. That is, horizontal component equal to u cos theta and a vertical component u sin theta. where u is the velocity of projection and theta is the angle of projection as shown in the figure. So y is u sin theta and x component, horizontal component is u cos theta. The horizontal component remains unchanged due to uniform motion throughout the flight. Hence, Vx is equal to, we know, Ux plus At, where V is the x horizontal component and U is the horizontal component of velocity U, and A is the acceleration and T is the time. That is given by the relation equals Vx is equal to U cos theta, because in the horizontal component acceleration is 0 and the displacement x is given by the equation ux plus half at square, and because a is 0 here in the horizontal component, it is x is equal to uxt, that is ux is u cos theta into t. Let it be equation 2. Point number 4. The vertical motion is a motion under gravity. So there is an additional factor g in the vertical motion. This is given by the relation velocity vy is equal to uy plus ayt. That is equal to u sin theta. Uy is u sin theta minus gt. Ay is minus g into t, because a acceleration a is equal to minus g, that is free fall, and y is the distance. Y is given by uyt. Displacement y is given by vertical component uy into t plus half ayt square. Uy we know from the figure, uy is u sin theta into t plus a is minus g, therefore it becomes minus half gt square. Let this be equation 4. Using equation 1 to 4, problems of projectile motions can be solved. In the next 2 slides, we will solve some of the questions asked in your examinations. The first 2 questions are standard derivations. So in question number 1, it is asked, show that the trajectory of a projectile fired at an angle theta with a velocity u is a parabola. Obtain expression for 1. Velocity at any instant. Number 2 is time for maximum height. And number 3 is time of flight. So this is a 5 marks question that is likely to be asked in your academic examination. Answer. Equation for trajectory of a projectile. Trajectory is the path traced by the particle when fired at a certain angle with an velocity. So this is shown in the figure on the right hand side. So O is the origin, x-axis, y-axis, and this is the projectile fired at an angle theta, and it goes to the maximum height and then after some time it comes down. So equation for a trajectory of a projectile. We know from previous slide x is equal to u cos theta. That is, the distance along the x-axis is given by u cos theta, where u is the initial velocity and theta is the angle at which it is fired, into t. X is equal to u cos theta t. Therefore, rearranging, t is equal to x divided by u cos theta. And we also know the vertical position or vertical distance is y is equal to u sin theta t minus half gt squared, where u sin theta is the vertical component of the distance, t is the time, and g is the acceleration due to gravity or a free fall. These two are standard equations. Now we will substitute for t in equation 1. So that is, t is equal to x over u cos theta. Therefore, y becomes y is equal to u sin theta into t is x divided by u cos theta minus half g into x divided by u cos theta whole square. Therefore, y is equal to x tan theta, that is, u and u gets cancelled, sin theta by cos theta is tan theta. Therefore, the first term on the right hand side is y is equal to x tan theta minus half g into x square. This is the square, x square divided by u cos theta, that is the whole square. Therefore, y is equal to x tan theta minus half into gx divided by u square cos square theta. This equation is of the form y is equal to ax plus bx square. See here, x term is here, ax plus bx square, which is a standard equation for a parabola open downward. Hence, the path of projectile is a parabola. The first part of question is thus answered. Next, we will write the expression for instantaneous velocity vector v. Let vi be the instantaneous velocity of projectile at time t. Direction of this velocity is along the tangent to the trajectory at point P. So if you at point P, if you draw a tangent, then velocity is along the tangent to this trajectory at point P. Therefore, instantaneous velocity vi, vector vi is equal to vxi plus vyj. That is equal to square root of vx square plus vy square. This we have seen in the previous slide. Now this is the equation relationship for expression for instantaneous velocity. That is, vi is equal to square root of vx square plus vy square. Next we will take up time of maximum height. Time for maximum height. Please see the figure. Here the maximum height is reached at the almost center of this parabola and h maximum is shown here. Now we have to calculate the time at which it reaches to the maximum height. Let Tm be the time taken to reach the maximum height. At this position, that is at this position, Vy is equal to 0. Then 0 is equal to u sin theta minus g into Tm. Therefore, Tm is equal to u sin theta by g. Let it be equation 6. The time of flight. Next we will calculate the time of flight. The total time Tf taken by the projectile to go up and come down to the same level from which it was projected is called the time of flight. Please see the diagram. It is launched here and it goes to the maximum and comes back here at this point. That is same level as flight. Therefore, time of flight is the total time TF taken by the projectile to go up and come down to the same level from which it was projected is called time of flight. Applying y is equal to ut plus half at square. That is y is equal to u of y into t plus half ay t square. Therefore, y is 0. Therefore, u is sin theta into tf minus half gt square, because uy is equal to u sin theta and t is tf. Simplifying, we get t is equal to 2u sin theta by g. That is tf gets cancelled. Retaining tf, we get 2u sin theta by g. That is equal to twice of tm. This is the time of flight. Next is question number 2. Obtain an expression for maximum height, horizontal range and maximum range of the projectile. This is also a 5-mark question that is likely to be asked in your examination. The figure shown in the previous slides is reproduced here on the left hand side. Therefore, maximum height HM as shown in the figure, this is the maximum height, and though it is marked H, it is HM. Maximum height is HM. Therefore, at time T is equal to Tm, this is at this instant, time is Tm. H is equal to Hm. Therefore, we know that y is equal to uy into t plus half at square. That is equal to uy is u sin theta. Therefore, y is equal to u sin theta into t minus half gt square. This ay is gt. It is downward falling into free fall. That's why it is minus gt. Therefore, let it be equation 8. Therefore, we also know that from equation 1, Tm is equal to u sin theta by g. In the previous page, we have derived it. So let it be equation 9. Therefore, hence Hm will be equal to, in this equation, Hm is equal to u sin theta into Tm minus half g into Tm square. Let it be equation number 10. Therefore, substituting for Tm, that is we get this, that is Tm is equal to u sin theta by g. We get Hm is equal to u sin theta into u sin theta by g minus half g into u sin theta by g, u sin theta whole square by g square, because the term here is t square. That is equal to u sin theta whole square by g. This is u square. This is, you see, u square sin square theta by g. Therefore, u sin theta whole square by g, that minus u sin theta whole square by 2g. Therefore, maximum height Hm is equal to u sin theta whole square by 2g. Simplifying, that is subtracting u sin theta whole square by 2g from u sin theta whole square by g. We get u sin theta whole square by 2g. That is the equation required. That is, my expression for maximum height Hm is u sin theta whole square by 2g. Let it be equation 11. Next, we will calculate, we will derive an expression for horizontal range R. Please see the figure on the left hand side. Here, the projectile is launched at O at an angle theta and initial velocity u. It reaches maximum, it comes back. The horizontal distance R is shown here. The horizontal range is capital R. It is the horizontal distance traveled by a body during the time of flight. So by using the second equation of motion, we get R is equal to u cos theta into TF, that is ut. U is u cos theta into TF, that is equal to u cos theta into TF. We have found 2u sin theta by g. The time of flight, we know that it is TF is equal to 2 times Tm, that is equal to 2u sin theta by g. Therefore, R is equal to u square 2 cos theta sin theta by g. That is 2u sin theta is 2 sin theta is 2 sin theta cos theta is, we have written here again, u square 2 cos theta sin theta by g, that is equal to u square sin 2 theta, because 2 cos theta sin theta is sin 2 theta by g. That is the range, horizontal range. R is equal to u square sin 2 theta by g. Maximum range is maximum when, in this equation, in equation 12, if sin 2 theta is 1, then R is R maximum. Therefore, range is maximum when sin 2 theta equals 1. Therefore, sin 2 theta equals 1, that is sin 2 theta is 90 degrees. That is sin of 90 equal to 1. Therefore, 2 theta equals 90 degrees, or theta is equal to 45 degrees. A projectile will have maximum range when it is launched at an angle of 45 degrees to the horizontal, and maximum range Rm is given by the relation Rm is equal to u square by g. Hence, we have derived it. Now, having defined various physical quantities associated with projectile motion, we will take up some evert examples. Question number 7. Galileo, in his book Two New Sciences, stated that for elevations which exceed or fall short of 45 degrees by equal amounts, the ranges are equal. Prove this statement. This you have to give a proof. Range R is given by the equation R is equal to u square sin 2 theta by g. This is the derivation we have explained in the previous slide, slide number 3, where u is the initial velocity launched at angle theta. Now for angles 45 degrees plus alpha and 45 degrees minus alpha, 2 theta naught is 90 plus 2 alpha and 90 degrees minus 2 alpha respectively. The values of sin 90 plus 2 alpha and sin 90 minus 2 alpha are same, equal to that of cos 2 alpha. Therefore, ranges are equal for elevations which exceed alpha or fall short of 45 degrees by equal amounts. So, because the values of sin 90 plus 2 alpha and sin 90 minus 2 alpha are same, and that is equal to cos 2 alpha. Next question. A hiker stands on the edge of a cliff 490 meters above the ground. And throws a stone horizontally with an initial speed of 15 meters per second. Neglecting air resistance, find the time taken by the stone to reach the ground. and the speed with which it hits the ground. And also he has given in the question, take the value of g equals to 9.8 meters per second square. Answer: given u is equal to 15 meters per second. It is given here, you see. And a is equal to minus g, we know that is equal to minus 9.8 meters per second. And also y of t, that vertical distance, is given as minus 490 meters. So we are required to find the maximum time taken by this stone to reach the ground. Using standard formulae, we know that x naught is equal to uxt plus half at square equal to 0, because it is initial speed is 0. Therefore, and y horizontal speed is 0, and y naught is equal to uyt plus half at square is equal to 0. Using the equation, when we use equation 0, we get yt is equal to, when we put this value as 0, we get yt is equal to a half gt square. That is equal to yt is given as minus 490 meters, 0, here it is 0, minus half 9.8 into t square. Therefore, t is equal to this 2 into 490 is 980. 980 divided by 9.8, that is equals to t square. It will be 100. Square root of 100 is 10 seconds. So the time taken by stone to reach the ground is 10 seconds. Velocity components are Vx, that is equal to Ux, that is the horizontal component, and vertical component is Uy minus Gt, that is equal to Vy is equal to 0 minus 9.8 into 10. We have found the t as 10 seconds. That is equal to minus 98 meters per second. Therefore, the speed of the stone is square root of Vx square plus Vy square, that is equal to square root of 15 square plus 98 square, that is equal to 99 meters per second. With this, we have come to the end of our lecture on the projectiles. The next topic for discussions will be uniform circular motion given in chapter number 4, section number 4.11. Till then, goodbye.